So should I start?
You can
Sir,
start now.
okay. Sir, actually in today session, that is novel application on Python based machine learning algorithm implementation for wind speed prediction. In today's session, first of all, we will see what are the basic concept behind this wind speed prediction. After this, we will see 1 hour say published paper in say wind speed prediction, how we have done with the help of say one programming software and its implementation in say real life problem. After this, we will see one hands-on practice using uh, Python implementation of say wind speed prediction. So here, so now when we see say wind speed prediction, nowadays world is moving towards say renewable energy sources because non-renewable energy sources causes pollution which is hazardous to our health. So that's why nowadays this wind power generation from wind speed gain a huge interest. So now how we can generate power from wind? So the power equation of wind is directly proportional to wind speed, and this wind speed can be measured by say anemometer. So the main problem is that anemometer is not installed throughout every sites in of different countries. If we take an example of India, so we are not having installed anemometer for different sites because it make huge cost. So that's why here this machine learning algorithm or different predictive model come into existence. When we talk about say wind speed, it is stochastic variable. What is meaning of stochastic variable? It means that it changes drastically with time. If we consider say 7 p.m. at this time, it will change after in upcoming say 8 p.m. or 9 p.m. So in some sites of India, it changes drastically, but it sometimes it not changes drastically. That is called as a stochastic natures of the wind speed. Now here we will see what we mean by say prediction. Now prediction means here we have to take input features of wind, then we have to develop the models. Once the model are developed with the help of say training and testing data, then we can use that models for prediction. That is the meaning of the say predictive models. So here why we require this wind speed prediction? So its major application in say renewable energy, you can say here weather forecasting, aviation industry, and environmental safety. So we can say that this predictive model is helpful in these application. Now here the question arises how we can do accurate prediction. Why we require accurate prediction? So its answer is that it
Sir,
is used in say
please make full size of the presentation, and also it is not moving. We
no
can see
no
only.
actually I am in first slide.
Okay, so please make full size,
Yes, it is full side from my side.
but here not full size.
It is sir full side from my side. I am sir. Now side it is okay.
Not yet, sir. Press F5.
F.
F5.
Okay, let me see. Shift F5. It is for volume here, I think so. Okay. No.
Or either you can do from the slideshow.
Yes, yes, I can do here from the.
Yeah, from this place.
Okay, now come in.
Uh, Not yet. It is not in full size.
Actually,
There are several icons on the top from beginning from current site. Please press from this place.
this one,
At the next taskbar.
this one.
Yes, yes, yes.
I pressed it, sir. It is showing full side from my side.
No, no.
Please reshare the screen. Share it from entire.
Again from
Unshare the screen, then share again.
stop sharing.
Yeah, now
Right.
share again.
So all window.
Entire first left side, top left, entire
Top
window.
left.
Entire.
Here entire is not coming. Here your this skin is coming. Okay, here this one you are saying top left.
Yeah. Now
Okay.
do the full size slideshow.
Now it's coming.
Yeah, it's fine. Fine now.
Okay. Okay.
It's fine now. It's okay.
Okay. So here we are discussing about say what is the importance of this accurate wind speed prediction, where it play a important roles, like say optimizing say wind energy production. Then with the help of this we can enhance the grid stability. Apart from this, there are say different methods in say wind speed prediction. First one, we are using this traditional method such as staticals and numerical weather prediction. But there is the limitation in traditional method that these methods are unable to track complex non-linear and highly variable natures of the wind patterns. This is the main problem. Otherwise we can use this hard computing. Previously so many researchers have used this hard computing, that is called as a statistical methods or numerical weather prediction in say wind speed prediction. But due to this limitation, that due to stochastic natures of the wind, these methods are unable to track this complex non-linear and wind pattern. That's why this machine learning model came into existence in terms of prediction in field of wind. Because in machine learning models, it captures non-linear complex relationship between the data. Now here, what is the main problem here? Where input variable is also changing with respect to time, and target variable is also changing with respect to time. And this changing is not say in the steady form. It is in say stochastic form. Means we cannot say that what will be the value of say wind speed in upcoming say 1 hour or 1 hour ahead or 10 minutes ahead or 1 second ahead or 5 seconds ahead. These stochastic natures of the say wind speed we can capture with the help of the machine learning models. So now from this onward, we are going to see how we can use this machine learning model in say wind speed prediction. Now here, what are say different important parts in say wind speed and when we are developing the model? Now first part here, we have to record the wind speed with the help of say anemometer. Anemometer is nothing but it is a sensor. that is say sensor equipped with say data loggers, and that data loggers is equipped with the computers. So with the help of these sensors, we are able to record wind speed at different instant of time. Now here, quality and accuracy of the weather data. This is very much important, because once our data is not of the quality form, then we cannot use that data for say predictive predictive part, because once we develop our model, that model is not so much accurate. As we know that machine learning model is totally dependent on the data, so our data should be of highly quality. So therefore here this sensor calibration come into existence. So here we in wind speed we are using this anemometer. Therefore calibration of this anemometer should be accurate. Otherwise, there will be significant error in the predict. After this here, when we are going to record this data, sometime the missing value will come. Sometime the missing value will come. It means that means there is gap in the data. Now, how we can remove that gap in the data? So we have to fill there the missing value. Otherwise, this gap in the data, it causes so training error, and again it adds a complexity and inaccuracy in the model, right? Next part is say limited historical data or inconsistent data frequency, insufficient data. So suppose we have to develop say wind speed say predictive models. So if it has say insufficient data, it means that limited amount of historical data, right? In that case also it is difficult to train robust model. So that is most important part. Next one, inconsistent data frequency. Suppose if we are not collecting data at say regular interval, okay, some day have say multiple measurement while other day have none, it make it challenges to establish reliable pattern. So what we can say from this point, that our sensor should be calibrated and it should be of say high quality. So that's then we are able to record more accurate data. After this here, how we can integrate diverse data source. First of all, there should be a development of say weather station. So data from say weather station provide point measurement, but it may not capture spatial variability of say wind pattern. In some cases we are using this satellite image. So with the help of this we are able to capture say broader view of say atmospheric condition, but it may not have the same level of details as ground based measure data. Now here, why it is so? Because at say we have to develop the model at say ground level, and satellite used to measure the wind speed at a certain height. So therefore, there is the difference in the measurement from ground level as well as the satellite image. So when we are using this satellite image data for any application, so result is not as much accurate, but at places where we are not having this measuring instrument, so there we can use this satellite data and perform our analysis. Next one, integrating data from different sources can improve accuracy of the prediction. So this is very important part. So we have to integrate data from say different sources. Suppose we have done measurement from one side and other side with different types of say instrument having say different accuracy level. Then we have to integrate all that data source to improve the accuracy of the prediction. Next one, handling non-linear relationship between the variables. So this wind speed is influenced by say multiple factors like say here with the difference in say solar radiation intensity the wind speed also get different. So therefore there is a complex relationship between the input variables and say output variables, and this relationship is not linear, right? So that's why here this linear model may not be sufficient to capture this complex relationship. So this is so that's why here linear model always give you say more error. Next point. Now here we know that for developing the model we requires input features and say target variables. Now here there are say different input features. From those input features we have to select the relevant features. Otherwise our model will give you say more predictive errors. So now here the question arises how we can select the relevant features. The relevant features. So in this case, suppose we have to see what are the dependent variables of the say wind speed, right? So for example here temperature, pressure, humidity, solar radiation, right? These are say dependent no sorry independent variables of the wind speed on which this wind speed get dependent, right? From these variable we have to select the relevant feature. What do you mean by relevant feature? It means that that variable which influences wind speed more, that is called as a relevant features. Here we have to find out the correlation between the target variable and each input features, and we have to see which variable is having most correlated value, and we should keep that variable, and we have to neglect least correlated variable. So with the help of the basic concept of the correlation variables in mathematics we can select the relevant features. But apart from this there are different methods available in literatures for relevant features, such like say rapid miners we are having. Apart from this we are having different Brapper techniques. Then we are having this optimization techniques. Next one here, what are say spatial dependence? Means bin pattern can vary across different location. Ignoring spatial correlation can lead to inaccurate prediction. Then we are having temporal dependence. Wind speed can exhibit temporal pattern. Example, diurnal variation, seasonal trends. Incorporating temporal dependence can improve prediction accuracy. Handling non-stationary and seasonality. Non-stationary, here wind pattern can change over time due to various factors like climate change or change in local condition. This model need to able to adapt this change. So here adaptability of the model come into existence. Then we are having seasonality. Again, we are just here seeing that the different parameters which affect the wind speed. So that parameter we have to take it into account. Then we are able to develop the accurate model. Next one here, wind patterns can exist can exhibit here seasonal variations. Incorporating seasonal information can enhance accuracy of prediction. Now, when we are developing the models, we have to check these parameters like overfitting. With too many parameters can fit the training data too closely, leading to poor performance on new data. So then we are having underfitting. A simple model may not capture underlying patterns in the data. Then how we have to select the accurate model? So we have to find the right balance between model complexity and simplicity is crucial for achieving the optimal parameter. So here it is called as a bias trade-off. So with the help of this bias trade-off, we are able to find out the optimum point between overfitting and underfitting. Now, what are say different parameters which affect wind speed, like say turbulence, intermittent behaviors, local topography and terrains, weather parameters, diurnal and seasonal variation. Now here, before this, we have discussed about say important features, right? How we have to select the important features. First of all, first of all, we have to load the data sets. Suppose here we are having the different input features and target features. First of all, we have to load that data set. Then we have to apply say data pre-processing techniques here. Say data pre-processing technique. So here in Python you will find out say min-max techniques, okay, which is already available in its library. Then here we have to develop the correlation analysis. Correlation analysis means correlations between say input variables and say target variables, and we are able to calculate the correlation matrix. How we will read the matrix? If your value r is equal to 1 or less than 1, then it is called as perfect positive correlation. If value of r is equal to -1, then it is called as a perfect negative correlation. If value of r is equal to 0, then it is called as a no correlation, right? So once we are able to find out here the correlation matrix, then we can easily find out what is the relevant features for the predictive models. Then try to see this graph I have developed in say Google Colapse. So here, try to see here. Here we are having say different input variables. Here we have taken. Now here try to see here wind velocity. Okay, so wind velocity corresponding to itself is having say one variable 1. So wind velocity correlation of wind velocity with pressure here 0.17. Then here with temperature again here 0.10. Then again here teapot temperature, then here 0.11. Then here temperature dew point here. Now we can see here we are having negative correlation. Here we are having negative correlation. Again here we are having negative correlation. Negative correlation. So we directly remove this negative correlation, and we should take only that input features which are close to 1, right? So with the help of this correlation matrix, we are able to find out the relevant features. Okay, so after this we are going to discuss one of our these uh, published papers in say wind speed prediction. It is published in say renewable energy. Elsewhere have been impact factor more than 8, and it is in say CI have been say QR ranking. So you can find it on net. It is available there. So now here we will discuss how we have developed the models, and how we can use that developed model in predicting wind speed for sites where we are not having the measuring instrument. Okay, so here directly come here. So here during our say research work, here our center located say at National Institute of Technology Hamirpur here. So on our centers, we are having this measuring devices, or you can say that we are having this meteorological department. So that is used to say collect the bin data. Okay, so our main objective is that. So here at our center, so when you see this data of Himachal Pradesh, so our center is located in Hamirpur. So we have to develop the model here, okay, by collecting data at this site, and we have to use that model to predict wind speed data for this site. Now this is a mountainous region, and these regions are not having say measuring devices. Now, how we can estimate wind speed for this site? This is close to say upper Himalayas. Again, this Kullu, again it is close to upper Himalayas, right? So that's why in that say problem statement we took, and we develop a model based on say measuring instrument what is installed at say the here Hamidpur, right? So try to see, first of all we have to describe all these locations. Okay, so here location in terms of latitude, longitude, altitude means above sea level. That is important part. Next, and so this also you can use in your at your research work nowadays. Again, this is again one of the major research area which you can use. Sorry. Now uh, try to see here, these are the sensor propeller type anemometer. It is say 18.5 meter above say ground, right? Here this is called as a anemometer. It is used to record wind speed. Then here you are having this cup type anemometer. Again we are recording the wind speed. Here you are having wind vane. It will provide you the direction of the wind. Okay, next here you are having this pyranometer. It is used to uh, take measurement of the solar radiation. Then here you are having this relative humidity sensor, this part. So these are the, you can say here, automatic bin monitoring station at energy centers in NIT Hamirpur. So with the help of this monitoring station, we have collected say different data. Now you see here, these are say technical specification of wind monitoring instrument and say sensors, right? So here how we can evaluate the different parameter like this range, accuracy, resolution, operating temperature, then here output. After this here, now you see here, we collected here daily variation of average wind speed at 10-minute interval. Okay, so we have collected these also, you can say throughout the year, and we took this data and plot a graph here. After this, we have used these NN models. So how we can uh, find the accuracy of the NN model with the help of say mean absolute percentage error. Its equation is 1 by n, summation I is equal to n. So wind speed which is predicted by NN model, and this is a wind speed which is measured by our measuring instrument. So now here, in any model, when we are getting say mean absolute percentage error less than 10%, it means high prediction accuracy. If we are having mean absolute percentage error between 10% to 20%, it means good prediction, right? If mean absolute percentage error is between 20% to 50%, then we are having reasonable prediction. We are having mean absolute percentage error which is greater than 50%, then it is inaccurate prediction. So we can say on the basis of mean absolute percentage error, we will decide in which range our model is coming, right? Apart from this, we are taking this average temperature, maximum temperature, minimum temperature, solar radiation, and altitude. Some values, like we can say, we took this value from this National Aeronautic and Space Administration (NASA) database. Because why we are taking these values from say NASA database? Because these values are available for say different sites. That's why we have to take these values from NASA database, and we took the value of say wind speed at say 10 meter, 20 meters height installation of say anemometer. Now here, so this is the say pictorial diagram which we have used for ANN architecture for daily wind speed prediction. Right? Try to see here. Here average temperature, maximum temperature, minimum temperature, air pressure, solar radiation, altitude. Then here on say target variables, we took here say daily wind speed. Right? So based on this say data value, we have developed the models, and here we have used this two-layer feed-forward neural networks. Okay, two-layer feed-forward neural networks. Here we have used say Levenberg-Marquardt algorithm. Right. So this algorithm is available in say MATLAB. You can say that you will find in say MATLAB toolbox also. So first of all, what we have done here, data are randomly divided into 60% training, 20% testing, and 20% validation. Right. So based on this data, we develop the model in say MATLAB. Now here one important parameters we have to keep in mind, how we have to decide the hidden layer neurons. How we have to decide the hidden layer neurons. This is decided by say equation 2. Try to see this Equation 2. Here number of hidden layers neurons, number of data samples, here number of say data samples used in say NN models, IN say number of inputs, ON number of outputs, right? So here the training automatically stop when generalization stop improving as indicated in the mean squared error of validation data samples. Training multiple times will give result due to different initialization of the connecting bit. Now, using all this concept, we develop the models. Now we will see here. Now this one, we have to. Now we are having say 6 inputs. We have to check on which multi-layer feed forward architecture we are having less mean absolute percentage error. Now here we are checking this is a 6 16 1 means 6 is the input, 16 is the hidden layer neurons, 1 is output. Again we have to change to 17 and check mean absolute percentage error in testing. Again we should change here say up to say 26. Here there is the equation, this one, that is the hidden layer neurons equation, this one. Okay, here how much hidden layer neurons we should keep, this we will get from this equation, and we should add here say plus minus 5, right? This is a standard part. Based on this we are getting here 16 17, and we have to train the model, test the model. Okay, and we will see here when we are having say hidden layer neurons say around say 25, we are getting less value of say mean absolute percentage error, right? So this value of hidden layers neuron get different as per different application. So we should keep here say hidden layer neurons at say 25, and we are getting here say mean absolute percentage error for testing. If you are having any problem you can ask to me, right, here in between this. Now we run the models and we are getting here say performance plot. Okay, so try to see here performance plot. Here epochs is one complete sweep of say training, testing and say validation. So now you see here when we run the models, we are getting here mean square error, it get decreases as number of epochs get increases. So at this point at say epoch 4, we are having say best validation performance, that is given here 0.17, right? So this is the performance plot. So with the help of say performance plot we can see what are say different error parameters in the models. Next here, try to see here regression plot, right? So regression plot here, here we are getting the value r is equal to say 0.98. So try to see how we can analyze this plot. Here y is equal to mx plus c. So this m should be close to say 1, right? So here this is perfect fitting, but this perfect fitting not possible in real world application. So that's why we are not getting all data on this line. Okay, so this is the beauty of this plot. By seeing the plot we are able to find out the real world application graph, right? So that's why here this dotted line, it is called as y is equal to t, but it is not happening. This small circle size so the data here r is equal to say 0.98. After this here, we have compared the ANN predicted and measured value. This is important. So in this graph, we have compared the ANN predicted value and measured value. So try to see the here comparison here. We are getting the predicted value is close to the measured value, right? After this, what we have done, we use that model, this developed model, for predicting the wind speed for other site which is close to the Himachal Pradesh. So that's why we predicted say daily wind speed at say Bilaspur. Next one here now say here Chamba. Okay, all this wind speed throughout the year at say Chamba location. After this we have predicted the daily wind speed at say Kangra. Here try to see here this Kangra. Next here this Kinnor. Again, these are say you can say that site are in say complex terrain, and these site are not having any measuring instrument. Okay, so that's why and these are you can say that major application, or you can say that major threshold of our this research article. So we have predicted this wind speed at say Kinnor. Next here at say this Kullu, right? After this here say Keelong. Keelong is one place. Then Mandi. Then here Simla. Then here Sirmaur. Then Solan. Then Una. Okay. So based on this predicted value, we have just here find out the range in say different month of all these sites now after this we have done one say a case study with the help of say micro wind turbine. Okay, just for our miss comments as per the reviewers here, the power which is given by wind turbine here half rho AV cube. This is here wind power. Then here we took this wind turbine here, and based on this wind turbine, we have calculated the predicted power. Now here we have used here micro wind turbine. Why it is so? Because these wind turbine can produce power at say minimum speed. So that's why here we are using this micro wind turbine to see its wind power potential as this site. After this, we have estimated how much power these sites are having. So, so in this way, we have developed our research articles, and these research articles got say published in say renewable energy Qwa ranking journals. So, if you also want to develop these type of models for your site, you can also develop. So, based on this, we will do some Python, how we can use this Python for say prediction of say wind speed. So now here, first of all, we will see say data profile. First of all, we will see say data profile. So so these data initially we took here, but you can take your own data. So light here we have seen this wind speed is dependent on temperature, maximum temperature and minimum temperatures. So these are say input features, these are say target features, and we took these data, right? You can take your own data. So here we will see how we can use this Python programming for wind speed prediction. So first of all, open say Google Colab in your say laptop. If you want to practice this program, you can practice. Then what we have to do, import say numpy, which is given as say np. Then here pandas as pd, scalar, then here scalar, then here preprocess. Then here import tensors keras model, then tensor keras layer, tensor keras optimizer, scalar matrix import mean square error, mean absolute error, right? So this is the beauty of this Python library. We are having enrich library, so we have to import say different libraries. So at this point, from this window, we have to upload the data. At this point, we have to upload the data, right? Then suppose we are going to uploading this data here. Then we can upload the data from this point. Okay, bin dot xls. So here your data will be any format, that csv format, xls format, right? You should see. So next here, upload the data set from google.colab import file. Uploaded is equal to files dot upload. Now here, load the data set from uploaded file, means this one. From this file we can upload the data, or if you want to upload from here, mount it in a drive, you can do from here also. Then here display the first few row of the data sets, right? Print data set or data head. Next here, just here replace feature 1, feature 2, feature 3 and target with textual column. So these are say input features, these are say target variable. We should write this name, okay, because this name is written here, input 1, input 2, input 3, and here SR. Okay, so here we should write out all these names. Next, split the data into training and testing, right? So for testing, we are taking here say 20% data, and rest 80% data we are giving for training. So therefore here we have to define the test side as say 0.2, right? After this here, standardize the input features. Input features means here scalar, standard scalar, ex train scalar dot fit transform ex train. Then here ex test means this is for say data pre-processing. Okay, this we are using for say data pre-processing, right? After this we have to define the MLP model, right? Define the MLP models. So here input layers with 3 features, hidden layer 1. Okay, here try to see here hidden layer 1, then hidden layer 2, then here output layer for regression. In output layer for regression, we are using here say linear regression models, right? So here in output, why we are using this linear regression model? Because say y is equal to mx plus c. What are the input we are getting after the using this activation function? Then with the help of that activation function, we used to give the output. After this here, so once we define this MLP models, we different say here activation function. Here in input layer, we have to decide say neurons and activation function. Again, hidden layer 1, hidden layer 2, and output from that. After this here, compiles the models, right? We have to compiles the model in the bit. Then we are using loss, means how we have to calculate the error with the help of say mean square. Then here train the model, right? So here train the model. Then here we are having epochs, that is 100. Batch site 32. Validation split we are having 0.2. Then how we have to evaluate the model? Means once we have developed the model, then we have to build the model, then how we have to evaluate the model. Three part are important. So here mean absolute error on test set. So for mean absolute error here, this part is important. These are standard code. Next one, predict bind speed for the text data. Now we have splitting the data. So 0.2% we are taking for testing the data. So that data we are using here for so testing the model. Next here, calculate evaluation matrix, means mean square error. So these are means you can say that statistical analysis for error analysis of the model. This part will give you the accuracy of the model. So first one you can use mean square error, root mean square error, mean absolute error. So by using this coding, we will get mean square error. By using this one, we are getting root mean square error. By using this one, we are getting mean absolute error. Right? So these are the calculation part. After this here, we have to print this error. Okay, print this error. This one say mean square error, root mean square error, mean absolute error. So with the help of this one, we have to print all these evaluation metrics. Next one, how we can visualize the all this figure. Okay, so for this we have to import this library matplotlib as plt, right? So here these are say different figures. So here loss means error, is training loss. Then we are having validation loss. Then what title of the plot we should keep here, like model loss during training. Here loss mean square error. Here epochs. Epochs is that one complete sweep of training, testing and validation. Here we are having this plot training and validation part. Okay, so these are different types of plot which is created on these models. Okay, so let me run this model. Okay, so actually this model is um, automatically we can run. We can develop this online Google Colab here. Here now is coming. So we have to choose the file. Choose the file. This file we should keep here. We are choosing this file here. Okay. Try to see here. It is running. Okay. Try to see here. Epochs are say complete sweep of say training, testing, and validation. So this is say running here. Again, it is running. Let it come. Then we will analyze all this plot here. Try to see here. We are having say mean absolute error on test says 0.076. Okay, before this, try to see what do you mean by epochs. Okay, now here epochs is one complete sweep of training, testing, and validation. Right. So here try to see here error. Again here error. Again here error. Try to see here error. Once the epochs is increasing, then the error get decreasing. Okay, so here try to see here error. Okay, mean absolute error, then validation loss, then validation mean absolute error. Okay, with the help of this all, once the number of epochs get increases, the error get decreases. Okay, so try to see here all the. So here we are having say around say 100 epochs. Okay, so error get decreases. So here mean square error. So here we are getting 0.008. It's perfectly trained. Root mean square is 0.009. Mean absolute error 0.007. Right? Try to see here loss mean square plot. This is the plotting. So with the help of this figure, we can see here this is a train loss. This is a validation loss. Both loss means error is decreases as the number of epochs get increase. Model a mean absolute error. Try to see how it look like training, right? How it miss next are say prediction using thun based. Am I audible? Okay, so that's all, sir, from my side. If I am opening the session for question answering, so if any participant is having any problem regarding the implementation of this bind speed prediction using Python programming, using MATLAB programming, they can ask to me.
Dear participant, if you have any question, please feel free to ask. You can unmute your mic. All the participants are in place, or either you can raise your hand for your question.
Or you can write your question in the chat session, okay? Then we can also reply.
Also, you can submit your question in the chat box.
Okay, so I will share all this code to you. Okay, all this code, all this data file, all the PPT will be shared to the organizer team. So as per the research paper are concerned, it is already available online. You can take help from that and implement this model at your site.
I think, sir, there is no question from the participant side because the content you present very nicely.
Okay, thank you, sir. It's my pleasure.
Actually, sir, this is very wide topic,
Yes,
right?
yes.
So very good, presentation was this one. So I need to little help, need help for this, but I will do
Okay.
exercise for that part.
Okay.
Yeah, then I will contact. Actually, right now I don't have question. Thank you.
Okay. Okay. So I write here mail.
I hope, sir,
Email
you can
ID.
understand because you have present
Yes,
your
yes.
research work.
Yes,
That is
yes, yes.
not
I
directly
understand.
easy.
Yes, yes, yes. I understand it. That's why I have written my email ID. You can
Yeah,
directly contact to me.
sure, sir. Thank you.
Dear participant, email address has been shared in the chat box. If you need any kind of help in the near future, you can contact Dr. Amit Kumar Yadav for his support. Sir, I think we should now close the session. Is
Okay,
there
sir.
any more content to present here? I think all the things has been present.
Yes, yes. I presented,
Yeah.
sir, all contents. Okay.
Thank you to all the participants to attend this session very nicely, and the questions which you ask has been cleared. And further, if you have any question or the problem in the near future, you can easily contact us for further help and stay connected. Uh, Today's session was on novel application on Python-based machine learning algorithm implementation for wind speed prediction, and the entire related to this paper has been discussed along with the Python code, how we can use the machine learning model and the different libraries which are available in the Python based. So the entire session is very interactive, very helpful, very informative to all the participant. And if all the participant, again, I am repeating the same, you need any kind of help from the speaker, you can easily contact email address is there, and you can stay connected with us also for any kind of the sport. Tomorrow we will resume the session at the same time, and the feedback link for the today's session will be available in the WhatsApp group. You can submit from that place, and the content which has been presented here will be available for you in the near for your future use. So thank you very much for the today's session. And once again, thank you very much, dear professor, for your valuable time and informative content. Thank you
Okay.
very
Thank you,
much.
sir. Thank you.
Thank you to all. Now it is time to end the session.